Hello, Tech Unplugged listeners, and welcome to another deep dive. Today, we're going to be, diving deep into the world of Microsoft Azure security. You sent over a ton of information, and honestly, it's a lot to process.
Yeah.
But that's what we're here for. Our mission today is to take all that and, distill it down to those key insights so that you can walk away with a solid grasp of, how to actually secure stuff on Azure without, getting completely overwhelmed.
Yeah. Sounds like a plan.
Yeah, and I think a really good place to start is with identity, right? Because before you even start thinking about securing networks and data, you need to have a solid handle on who has access to what.
Absolutely. You're spot on. Identity is the foundation of everything in the cloud. And in Azure, that foundation is Azure Active Directory, or Azure AD for short.
Okay, Azure AD. Now, this is something I think a lot of people, especially those coming from a traditional on-premises environment, might initially misunderstand.
Right. It's tempting to think of Azure AD as simply like your good old on-premises Active Directory just, lifted and shifted to the cloud. But that's not really accurate.
Yeah, it's not just like, oh, I'm going to take my domain controller and stick it in a virtual machine in Azure. It's a completely different beast.
Exactly. Azure AD is specifically built from the ground up as an identity provider for the cloud. It's purpose-built for managing identities and access in this modern cloud-native world of applications and services, and it's what secures access to all those Microsoft cloud services like, Azure itself, Office 365, Dynamics 365, you name it.
So it's the gatekeeper for all things Microsoft Cloud.
Pretty much.
Now, let's say I'm an organization and I'm using a bunch of different Microsoft Cloud services. Like I've got some Azure VMs running for my applications. I'm using Microsoft 365 for productivity, maybe even some Dynamics 365 for, customer relationship management. Do I need a separate Azure AD tenant for each of those services?
No, you don't. And that's actually a really important point. You can have multiple cloud service instances all connecting back to the same Azure AD tenant. Think of it like having one central key ring that unlocks all the doors to your Microsoft Cloud kingdom.
That's a great analogy. So one Azure AD to rule them all.
Exactly. And it's pretty common for organizations to have, multiple Azure subscriptions, maybe for different departments or environments like dev, test, and production. But all those subscriptions can still use that same central Azure AD for identity.
Okay, so it's centralized identity across all my Microsoft Cloud stuff.
Exactly.
Now, walk me through what happens behind the scenes when I try to log into something like, say, the Azure portal. Where does Azure AD come into play?
Sure. So when you go to the Azure portal and try to log in, the portal itself doesn't actually handle the authentication. It actually redirects you to Azure AD. And Azure AD is the one that checks your username, password, and any other authentication factors that might be required. And only after Azure AD gives the thumbs up, basically saying, yep, this person is who they say they are, does it send you back to the Azure portal and you're granted access.
So it's like Azure AD is the bouncer at the club, checking your ID before letting you in.
You got it.
Now, if I'm an admin and I'm managing my Azure AD, what are the key pieces of information I need to know about my tenant itself?
Every Azure AD tenant has a few essential identifiers. One is the tenant ID, which is a globally unique number. It's kind of a social security number for your Azure AD. And then you have the primary domain name. And when you first sign up, this usually ends in .onmicrosoft.com. But you can add your own custom domain names, which is highly recommended.
Yeah, that makes sense. So instead of having mycompany.onmicrosoft.com, I could just have mycompany.com.
Exactly.
It just looks more professional and it aligns with your brand.
Absolutely. It's all about that user experience and that trust, right?
Right. Now, Azure AD, it's not just a one-size-fits-all kind of thing. There are different editions, right? Can you walk us through those and when I might need to consider paying for a higher edition?
Sure. So you have the free edition, which is, included with your Azure subscription, and it gives you the basic identity and access management features. Then you have Office 365 apps, which, as the name suggests, is included with Office 365. It gives you some additional capabilities for managing users and groups. But if you're serious about security and want to take advantage of more advanced features, you'll need to look at the premium editions, P1 and P2.
Okay, so premium is where the really good security stuff is.
Exactly. Features like identity protection, which uses machine learning to detect risky sign-ins in real time. And then you have privileged identity management, or PIM, which lets you grant temporary time-limited admin access rather than having people be permanent admins.
So that's the, just-in-time access for admins.
Precisely. And that's a huge security best practice, right?
Yeah.
Because if someone only has admin rights for a short period when they actually need them, it significantly reduces the attack surface.
Yeah, absolutely. Now, within my Azure AD tenant, what kinds of things am I actually managing on a day-to-day basis?
Well, primarily you're managing users and groups.
Right.
You can create users manually, or you can sync them from your on-premises Active Directory if you have one.
Okay, yeah, the hybrid scenario. We'll get to that in a bit.
Right. And for groups, you have static groups, where you manually add and remove members. And then you have dynamic groups, which are super powerful.
Dynamic groups. Tell me more.
So with dynamic groups, membership is automatically determined based on user attributes, like their department, location, or job title. So if someone's job title changes, they can automatically be added or removed from the appropriate groups.
So it's like self-managing groups based on rules.
Exactly. It really helps to reduce admin overhead and ensure that group membership is always accurate.
Okay, dynamic groups are cool. Now let's talk about permissions. I know Azure resources have their own role-based access control, or RBAC, but what about Azure AD itself? Does it have its own separate system for managing permissions within the identity platform?
It does, and that's a really important point. Azure AD has its own RBAC system that's completely separate from the RBAC you use for managing Azure resources like virtual machines or storage accounts. Just because someone has, say, global admin rights in Azure AD, it doesn't mean they have full control over your Azure subscriptions. Those are separate realms of permissions.
So two different sets of permissions, one for Azure AD itself and one for the actual Azure resources.
Exactly. And this separation of duties is super important for security.
Now, you also mentioned something called service principals earlier. What are those and why are they important?
Service principals are basically identities for applications and services. It's like a non-human user account that allows an application or a script to authenticate to Azure and access resources. This is way more secure than embedding like usernames and passwords directly in your code.
Yeah, that's a big no-no in security.
For sure. Service principals are essential for secure automation and for allowing your applications to work with Azure services without requiring human intervention.
Okay, so service principals are like robot users.
Yeah.
Makes sense. Now let's talk about organizations that already have on-premises Active Directory. How does Azure AD fit into that picture?
For those organizations, there's a handy tool called Azure AD Connect. And this tool helps you sync your on-premises AD identities with Azure AD. So you can have what's called a hybrid identity system.
So it's bridging my existing on-premises identity world with the cloud.
Exactly. This means your users can use the same credentials to access both on-prem and cloud resources. It's all about that single sign-on experience.
That's super convenient. But wait, does that mean my actual passwords are being copied up to the cloud? Because it sounds like a potential security risk.
That's a good question. And thankfully, no, your actual passwords aren't copied directly. Azure AD Connect offers different methods for handling authentication in a hybrid scenario.
Okay, good to know.
One method is password hash synchronization, or PHS. And what happens here is, instead of copying the actual passwords, it syncs cryptographic hashes of the passwords from your on-premises AD.
Okay, so it's more like a fingerprint of the password, and it's computationally difficult to reverse those hashes back to the original passwords.
Exactly. It's a much more secure way of syncing passwords.
Now, what about the other authentication method you mentioned for hybrid identity?
Right. The other one is federation. And with federation, when a user tries to access a cloud app, they're redirected to your organization's on-premises federation server, something like Active Directory Federation Services, or ADFS. And this on-premises server actually handles the authentication.
Okay, so the authentication stays on premises.
Yes. Azure AD trusts the assertions made by your federation server, so the password hashes are never actually stored in Azure AD.
Got it. So for those highly regulated industries where, like, keeping passwords entirely on premises is a requirement, federation is the way to go.
Makes sense.
Now, whether I'm syncing passwords or using federation, what's to prevent users from choosing weak passwords in the first place?
That's where Azure AD Password Protection comes in. This feature helps you enforce strong password policies across both your on-premises AD and Azure AD.
Okay.
It uses a list of known weak passwords and prevents users from setting those.
So, like, password 123 is a no-go.
Definitely. You can even customize this banned password list to include, specific terms or patterns that are relevant to your organization.
Oh, that's smart. So if your company name is Acme, you could block people from using Acme in their password.
Exactly. It's a really effective way to enforce good password hygiene.
Now, let's move beyond just the basic authentication piece and talk about controlling access based on a bunch of different factors. And this is where I hear the term conditional access thrown around a lot.
Well, conditional access is a huge one.
It is, but it can also be, well, a little bit confusing to understand.
Yeah, I get that.
So in plain English, what is conditional access and why is it so important?
So conditional access is basically a set of rules that you define that allow you to control when and how users can access your applications and data based on various conditions. These conditions can be things like the user's location, the device they're using, the risk level associated with the app they're trying to access, even the sign-in risk itself.
So it's not just about are you who you say you are. It's also about are you accessing this from a trusted location? Are you using a managed device? Does this sign-in look suspicious?
Exactly. So let's say you have a policy that says if someone is trying to access sensitive financial data from a device that's not managed by the company and they're outside the corporate network, then block access. That's something you can do with conditional access.
Oh, that's super powerful. And it really aligns with that whole zero trust security model, right?
Absolutely. Zero trust is all about never implicitly trusting anyone or any device and always verifying before granting access. And conditional access is a key enabler of that in Azure AD.
Now, with so much power at your fingertips, I imagine there's also the potential to, like, shoot yourself in the foot with conditional access if you're not careful.
Oh, for sure. One of the biggest mistakes people make is creating a policy that blocks access for, like, all users or all applications without thoroughly testing it first. You could accidentally lock everyone out of everything.
Oh, yeah, that would be a bad day.
Yeah, so
So,
start with a small pilot group, test it thoroughly, have a rollback plan, and then gradually roll it out more broadly.
now, you mentioned sign-in risk as a condition. How does Azure even determine the risk of a particular sign-in attempt?
That's where Azure AD Identity Protection comes in. This feature continuously analyzes sign-in patterns and assigns a risk level low, medium, or high to each sign-in attempt. It looks at things like unusual locations, impossible travel times, anonymizer services, and so on.
So if I suddenly try to log in from Russia when I'm usually in, California, that might raise a red flag.
Exactly. And you can configure your conditional access policies to respond to these risk levels. So you might say, if the sign-in risk is medium or high, enforce MFA, even if it wouldn't normally be required for that user or app.
Okay, so it's like an extra layer of protection based on behavioral analysis.
Exactly.
Now, speaking of extra layers of protection, let's talk about securing admin accounts. Because, as we all know, giving everyone permanent admin rights is just asking for trouble.
Totally agree. That's where Privilege Identity Management, or PM, comes in. And this is a fantastic tool for managing and controlling who has access to those all-important admin roles in both Azure AD and Azure itself.
Okay, so it's like a special access control system just for admins.
Yes. And the core concept here is just-in-time access. So instead of having people be permanent admins, you grant them admin privileges only when they actually need them and for a limited time.
So they have to, like, check out admin rights, and then they're automatically revoked after a certain period.
Exactly. And this process can include things like requiring a business justification, approval from a manager, even MFA. It's all about adding extra layers of security and accountability.
So if I need to, spin up a new virtual machine, I can request the necessary admin role, get approved, do my thing, and then those rights are automatically taken away.
Exactly. And this significantly reduces the risk of, someone's admin account being compromised and used maliciously.
Yeah, and it also helps with that whole principle of least privilege, right?
Absolutely. You only grant people the access they absolutely need to do their job, nothing more.
Now, what about keeping track of who has these privileged roles and making sure those assignments are still valid over time? Because things change, people move roles, and you don't want those old admin permissions just hanging around.
That's a really good point. And for that, PMM has this awesome feature called Access Reviews. And this lets you periodically review who has access to what. And it can even be automated. So you can set it up so that, say, every 90 days, all the owners of privileged roles have to review the people who have access and confirm whether they still need those permissions.
So it's like a regular security audit, but focused specifically on privileged access?
Exactly. It's a really good way to keep your admin permissions clean and tidy and to ensure that you're always following the principle of least privilege.
Okay, PIO sounds like a must-have for any organization using Azure. Now, let's shift gears and talk about network security. I mean, we're in the cloud, so we don't have our own physical firewalls anymore. How do we protect our virtual networks from all those nasty threats out there on the internet?
Right, network security is super important. And Azure has a bunch of different services to help you build a strong perimeter around your virtual networks.
Okay.
One of the first lines of defense is Azure DDoS protection. And this protects your public-facing services from distributed denial of service attacks.
Oh, yeah, those are the attacks where someone tries to overwhelm your website or application with a ton of traffic, making it unavailable to legitimate users.
Exactly. And Azure DDoS protection is designed to detect and mitigate these attacks, keeping your services up and running even under attack.
So it's like having a giant shield in front of your Azure resources, deflecting all that bad traffic.
Yeah, that's a good analogy.
Now, what about controlling the types of legitimate traffic that are allowed in and out of my virtual networks? Because I don't want just anyone connecting to my virtual machines or my web apps.
For that, you have Azure Firewall. And Azure Firewall is a managed firewall service that sits at the edge of your virtual network and acts as a central control point for all your network traffic. You can define granular rules to specify what traffic is allowed or blocked based on things like IP addresses, ports, and protocols.
So Azure Firewall is like the security guard at the entrance of my network, checking everyone's credentials.
Exactly. You can create rules to say things like, only allow traffic from this specific IP range to this specific port on my web server.
That's granular control.
Yeah, and it's essential for creating a secure network perimeter.
Now, my web applications are particularly sensitive because they're exposed to the public internet. Are there any specific security services designed just for web apps?
You bet. Azure has a service called Web Application Firewall, or WAF. And WAF sits in front of your web apps and protects them from common web exploits like SQL injection, cross-site scripting, and all those nasty things that hackers try to do to web apps.
So WAF is like a specialized shield specifically for my web apps.
Yeah, you can think of it that way.
Yeah.
And WAF is often deployed with a service called Azure Application Gateway, which is basically a load balancer for web traffic.
Okay.
And together, they provide a really solid security layer for your web applications.
Now, we've talked about protecting our networks from external threats.
Yeah.
But what about securing the traffic and resources within our own Azure environment? Like once someone's inside the network, how do we prevent them from, snooping around where they shouldn't be?
That's a great question. And for that, we have network security groups, or NSGs for short.
NSGs.
Yeah. And NSGs are like little firewalls that you can attach to subnets or even individual network interfaces within your virtual network.
Okay.
And they let you create very granular rules about what traffic is allowed between different resources. So, for example, you could have a rule that says, my web server can only talk to my database server and nothing else.
So it's all about segmentation and isolation.
Exactly. And it's a key security best practice.
Now, I can imagine that managing NSG rules for like hundreds of virtual machines could get really complicated. Is there an easier way?
There is. Azure has a feature called Application Security Groups, or ASGs. And ASGs let you group virtual machines that serve a similar purpose, like all your web servers or all your database servers. And then you can apply NSG rules to the entire group rather than individually.
Oh, that sounds much more manageable.
Yeah, it really simplifies things, especially in large environments.
Now, shifting gears a bit, what about the operating systems running on my virtual machines? Are there any security considerations there?
Absolutely. The choice of operating system image for your VMs is crucial.
Right.
It's a really good practice to use hardened images, which are basically pre-configured with a more secure baseline.
So they have all the unnecessary services disabled, the latest security patches applied, that kind of thing.
Exactly. And you can find a bunch of hardened images in the Azure Marketplace from trusted vendors.
Okay, that makes sense. And what about keeping those operating systems up to date with the latest security patches once they're running?
Right. Patching is essential. And Azure has a service called Azure Automation Update Management that can help you automate this process.
So I can schedule updates, track their progress, and make sure all my VMs are patched regularly.
Exactly. And, patching is one of those basic security hygiene things that you absolutely have to do, but it can be tedious to manage manually.
Yeah, automation is key. Now, let's talk about containers. They're becoming super popular for deploying applications, but they also introduce new security challenges. How do we secure our containerized apps in Azure?
Securing containers is a multifaceted thing. It starts with securing the container images themselves.
Okay.
And for that, Azure has a service called Azure Container Registry. or ACR. This is where you store and manage your container images.
Right.
And one of the most important things you can do is restrict public access to your registry. You can do this using a service firewall, which is available in the premium tier of ACR.
So I can limit who can pull images from my registry?
Exactly.
Yeah.
And for even more security, you can enable private endpoints, which means all traffic to and from your registry stays within your private virtual network.
Okay, so it's like putting my container registry behind a VPN.
Yeah, you can think of it that way. And then there's also vulnerability scanning, which is super important.
Vulnerability scanner.
Yeah, this lets you automatically scan your container images for known vulnerabilities before you even deploy them.
So I can catch those security flaws early on.
Exactly. And Azure offers a service called Azure Defender for container registries, which can do this for you automatically.
Now, once those container images are deployed and running, I'm often going to be using something like Azure Kubernetes Service or AKS to manage those containers. What are the security considerations for AKS?
AKS security is, well, it's a big topic. But some of the key things are using private clusters, which means the API server, the control plane of your cluster, doesn't have a public IP address, so it's not exposed to the internet.
Okay, so it's like putting my entire Kubernetes cluster behind a firewall.
Yeah, in a way.
What else?
Then you have controlling access to cluster resources. And for that, you can integrate AKS with Azure AD, so
Yeah.
you're using your centralized identity management system.
Okay, so I can use my existing Azure AD users and groups to manage who can do what within my AKS cluster.
Exactly. And then, just like with virtual machines, regularly updating the Node OS images is essential. AKS releases new node images with the latest security patches every week.
Keep those nodes patched. Always.
Yep. And within Kubernetes itself, you use role-based access control, or RBAC, to control access to different resources within the cluster.
Okay, so it's like a multi-layered approach to security, starting with the network, then identity, and then the individual resources within the cluster.
Precisely. And that's the beauty of Azure. You have all these different layers of security that you can apply to create a really robust defense.
Okay, let's move on to data security. I mean, at the end of the day, our data is often the most valuable asset we have in the cloud. How does Azure protect my data when it's just sitting there in storage?
Right. Data security is paramount. And Azure storage services offer a few different layers of encryption to protect your data at rest.
Okay.
By default, all data in Azure storage is encrypted using service-managed keys. This means Azure handles the encryption keys for you, so you don't have to do anything. It just happens automatically.
So my data is encrypted even if I don't lift a finger.
Exactly. But if you want more control over those keys, you can choose to use customer-managed keys, or CMK. And with CMK, you store your keys in Azure Key Vault, which is a dedicated service for securely storing keys and secrets.
So I have full control over those keys.
Yeah.
I can rotate them, revoke them, do whatever I need to do.
Exactly. And then on top of that, Azure offers infrastructure encryption, which adds another layer of encryption at the platform level. It's like defense in depth for your data.
So even if someone somehow managed to bypass the other encryption layers, they'd still hit this infrastructure encryption.
Exactly. And then there are also encryption scopes, which let you manage encryption at a more granular level.
Okay, so I could have different encryption keys for different containers or even individual blobs within my storage account.
Precisely. And it's all about giving you the flexibility and control you need to meet your specific security requirements.
And of course, we can't forget about encrypting data in transit.
Absolutely. Always enforce HTTPS for any communication with Azure storage services.
Secure those connections. Now, encryption is great, but it doesn't mean much if anyone can access that encrypted data. How do I control who's actually authorized to access my stored data?
For authorization to Azure storage, the recommended approach is to use Azure AD-based access control.
Okay, so again, we're tying everything back to Azure AD.
Exactly. With Azure AD, you can grant permissions to users, groups, and service principals based on their Azure AD identities.
And this is more secure than the old way of using storage account access keys and SAS tokens, right?
Yes, much more secure. Access keys and SAF tokens are long-lived secrets, and they can be easily shared or leaked, which is a security risk.
Yeah, it's like giving someone a master key to your storage account.
Exactly. So whenever possible, disable access keys and SAS tokens and rely solely on Azure AD.
So Azure AD is like the central nervous system for security in Azure.
You could say that?
Now let's talk about my relational databases in Azure SQL Database. How is the data within those databases secured?
Azure SQL Database offers a bunch of security features to protect your data. Similar to Azure Storage, all data in Azure SQL Database is encrypted at rest by default using transparent data encryption, or TDE.
So that's automatic encryption, like with storage?
Yep. And you should also enforce encryption in transit using TLS for any connections to your database server.
Always encrypt those connections.
Now, for particularly sensitive data, you can use a feature called Always Encrypted.
Okay.
And Always Encrypted actually encrypts the data within the client application before it's even sent to the database.
Wow, so even if someone compromises the database server itself, they still can't see the sensitive data in plain text.
Exactly. It's a really powerful way to protect your most sensitive information.
Now, what about controlling who can actually connect to the database server in the first place?
For that, Azure SQL Database offers two main authentication methods. The first one is SQL authentication, which uses the traditional username and password approach.
Okay.
But the recommended method is to use Azure AD authentication.
Oh, so we're back to Azure AD again.
Yep. With Azure AD authentication, you can use your cloud or hybrid identities to access your SQL databases.
So I can leverage all those security features we talked about earlier, like conditional access and MFA.
Precisely. It's a much more secure and manageable approach.
Okay, now we've mentioned Azure Key Vault a bunch of times as a place to store encryption keys. Let's dive a little deeper into Key Vault. What exactly is it, and why is it so important for security in Azure?
Key Vault is a fantastic service for storing and managing your application secrets, encryption keys, and certificates. It's basically a super secure digital vault for your sensitive stuff.
Okay.
And the main benefit is that it lets you centralize secret management. Instead of having secrets scattered all over the place in your code or in config files, you store them all in one place where you can easily control access, monitor usage, and rotate them regularly.
So it's like a one-stop shop for all my secrets.
You got it.
And access to Key Vault is tightly controlled through Azure AD, right?
Absolutely. You can grant very granular permissions to different users, groups, or service principals.
So I can specify who can read secrets, who can create new secrets, who can delete secrets, that kind of thing.
Exactly. And Key Vault also offers some really nice features to protect itself from accidental or malicious deletion.
Okay, like what?
One is soft delete, which means that when you delete a secret, it's not actually permanently deleted right away. It's marked for deletion and kept around for a certain period, just in case you need to recover it.
So it's like the recycling bin for secrets.
Yeah, kind of.
And then there's purge protection.
Right. Purge protection prevents even admins from permanently deleting a Key Vault or its contents until the soft delete retention period is passed. And even then, they might need to go through additional steps to actually purge the data.
So it's like an extra safety net to make sure you don't accidentally or intentionally nuke your secrets.
Exactly. And this is really important because, if someone compromises an admin account and tries to delete everything, purge protection can buy you some valuable time to detect and respond to the incident.
Okay, Key Vault sounds like an essential part of any security strategy in Azure. Now, let's zoom out a bit and talk about overall security governance and monitoring in Azure. How do I get a big picture view of my security posture, and how do I enforce consistent security standards across my entire Azure environment?
For that, Azure has some really powerful tools.
Okay, like what?
One is Azure Management Groups, which let you organize your Azure subscriptions into a hierarchy. So you can group subscriptions by department, region, or whatever makes sense for your organization.
Okay.
And then you can apply governance policies and access controls at the management group level, and those policies will be inherited by all the subscriptions within that group.
So it's like setting security rules at the top level that cascade down to everything below.
Exactly. It makes it much easier to manage security at scale.
Then there's Azure Policy, right?
Right. Azure Policy is a super powerful service for defining and enforcing security standards across your entire Azure environment. You can use built-in policies, or you can create your own custom policies. And these policies can cover all sorts of things, like ensuring that all storage accounts have encryption enabled, or that all virtual machines are part of a virtual network.
So I can define specific rules and make sure that all my Azure resources are compliant with those rules.
Exactly. And Azure Policy will actually alert you if there are any resources that are not compliant, and you can even configure it to automatically remediate those non-compliant resources.
So it's like having an automated security auditor that's constantly checking everything and fixing problems.
Yeah, that's a good way to think about it.
Now, what about actually getting visibility into the security state of my environment? Like, how do I know if there are any vulnerabilities or active threats that I need to address?
For that, Azure has a service called Azure Security Center. And Security Center is like your central security dashboard. It gives you a bird's eye view of your security posture. It provides recommendations for improving your security, and it can even detect and alert you to active threats.
So it's like my security command center.
Exactly. Security Center pulls in data from all sorts of sources like your Azure resources, your security solutions, and even Microsoft's threat intelligence feeds.
Okay.
And it uses that data to give you a comprehensive picture of your security posture.
Now, if Security Center is the command center, what about actually responding to those threats? Because just knowing about a threat isn't enough. I need to be able to take action.
Right, and that's where Azure Sentinel comes in. Azure Sentinel is a cloud-native SIEM, or Security Information and Event Management solution.
Really SIM.
Yeah, it stands for Security Information and Event Management. Basically, it's a system for collecting, analyzing, and responding to security events from a variety of sources.
Okay.
So Sentinel can ingest logs from your Azure resources, your security solutions, even your on-premises systems.
Wow, so it's like a centralized log collector for all my security data.
Exactly. And then it uses advanced analytics and machine learning to detect suspicious activity and potential threats.